we are going to, the next section of our unit is all about volumes and surface areas. On your formula sheet, there's a whole bunch of formulas that you get to use, and we also get to look at certain shapes. The first shape that we're going to look at is a prism. A prism is any shape where you have a certain shape on the bottom, like this Kleenex box has a rectangular on the bottom, and then if I put it down and the height goes all the way up the same as you go along, that makes a prism. You could have a triangle on the bottom and have it go up the same all the way along. You would have a triangular prism. So if you have a rectangle on the bottom, and this is going to be a little bit of art skills class too. Can you draw things in 3 dimensions? Yeah. Okay. So how do you draw things in 3 dimensions? You draw, and have to turn your computer on. We are going to draw a rectangle on the bottom, and on the bottom, when we draw that rectangle, we draw it sort of like it's laying on a table. It's kind of at an angle. Then we go up the same height on each of these and redraw that same rectangle on the top. The reason I drew dotted lines inside is because in reality you couldn't see those, right? If I hold the Kleenex box like this, you cannot see this back line. It's hidden. You can't see these bottom lines. They're hidden. So that's why we draw it like that. Sometimes prisms can be drawn, like I can draw a triangular prism with a triangle on the bottom. Oh, this one should have been dotted. That's fine. But is it not, if I take a triangular prism like that, and I accidentally bumped it over, and had it like that, is it no longer a prism? Or would you still say it's a prism? Right? If this is a Kleenex box, is this no longer a Kleenex box if I turn it? No, it's still. So when we have a prism, we often have a formula, and if you look at your formula sheet, let's say they have the volume of the prism on your formula sheet looks like this. The volume of the prism, and on your formula sheet it says, and I'll write it out exactly just so I'm not, it says this. I like color coding stuff. I find that color coding stuff helps you make connections and it helps you learn. So on your formula sheet, it says that the volume of your prism is area of the base times the height. And the reason I did area of base in green is because I'm going to take up my crayon pen, which is one of my favorite things to do, and color in the base in green. In this case, there's the base. In this case, there's the base. And on this one that's fallen over, that would still be the base. The shape that keeps the same shape all the way up is your base. With a rectangular prism, you have a choice. You could technically have this as the base and this is the height, Or if I flipped it like this, I could talk about this is the base and this is the height. It wouldn't matter. But if I went to a triangular prism, it's not the same shape going up when I use this part as the base. Only the triangle keeps the same shape all the way up. And so we have this as a formula. We're also going to talk about surface areas of shapes. Volume is how much it takes to fill something up. So my Kleenex box, if I cut open the top, filled it full of water, how much water it would hold would be its volume. The other formulas that we're going to be looking at is surface area. And surface area is if you try to paint all the sides of the shape that you have. So these are examples of prisms. We're also going to be looking at a shape called a pyramid. A pyramid could have any shape on the bottom. Here is a square pyramid. If I have a square on the bottom and pick some point as the top, and now I'm going to make some of these lines dotted, the ones that you actually wouldn't see. That creates a pyramid. So we're going to be doing some formulas with volume and surface areas of different shapes. And we're doing a little bit of an art class because you're learning how to draw certain shapes. It's a little bit of a challenge to do that. Some of you are going to attempt it and look at your paper and go, "Ooh, mine doesn't look like a pyramid at all." So we're going to start with surface area. So here's a review. To find the surface area of a right angle prism or a rectangular prism, we find the surface area of all of its sides and just add them together. And one of the things that can sort of help you visualize this, and again I'll use the Kleenex box, okay? If I came and I decided to paint all the sides blue, how many sides are there? There's going to be a front and a back, a side and a side, a top and a bottom. Can you see that there are 6 sides? Can you see that each of those 6 sides is a rectangle on this shape, no matter which way you look at it? So what we're going to do is find the surface area of 6 rectangles and then add those all up. Now that's going to ask you a question, do you remember the formula for the area of a rectangle? And if you look at your formula sheet, it's not on there. This is sometimes what happens in a math class. At a certain point, they feel like you've seen something enough that you should know it. So do you know the formula for the area of a rectangle? Do you remember it because you've done it lots from grade 7, 8, and 9? Length times width. So we're going to find length times width and add them together. So for our rectangular prism, there would be 6 sides, and each of them would have this formula for a rectangle, which is length times width. Let's make up some numbers here and actually do it. Let's say that this side is 3, this side is 5, and the height is 4. And we want to find the surface area. In fact, I'm not only going to make them 3, 5, and 4, units go along with it, because we'll often get questions where we have units as well. So we're going to find the surface area of this one, where the bottom is 5 centimeters, the one side is 3 centimeters, and the height is 4 centimeters. And there's a couple of ways that you could go about this. One strategy is to say, I know, think of a Kleenex box, I know there's a front and back, top and bottom, side and side. So one strategy would be to draw out all 6 of those triangles. And maybe to help yourself remember which one that you did, you maybe draw them out this way. Top and bottom, what are the rectangles that are on the top and bottom? So you draw a rectangle for the top, draw a rectangle for the bottom, and then it would be 5 and 3, 5 and 3. And in a different color, if I wanted to find the area of this one, 5 times 3, this will be 15 centimeters squared, 5 times 3, 15 centimeters squared. The total for the top and bottom, 30 centimeters squared. Some students will only draw one rectangle. Why? Because they will say the top and bottom top and bottom rectangles are the same. So I'm going to just draw one, but when I write the total, I'll times it by 2. Because that might save me a little bit of time. And that would be fun. Right now, just to really show that there's going to be 6 of them, I'm going to draw them all up. So now I'm going to go to my sides. Go to my picture, my sides, those rectangles. We're 3 centimeters by 4 centimeters. Length times width. My sides together will give me 24 centimeters. And the reason it was nice that I did a little bit of labeling, top and bottom and the sides, is if I just draw rectangles, sometimes, and this might happen to you, sometimes you get done the 4th one and you're like, which ones haven't I done? And you've forgotten which ones you've done. So the labels sort of go, okay, which ones haven't I done yet? I've done the top and bottom and the sides. Which ones haven't I done? The front and the back. So it kind of, the labels help us remember what we've done. Then I look at my picture. What does the front and back look like? That would be 5 here and 4 there. And units-wise, notice that lengths are measured in centimeters here. The area is measured in centimeters squared. So when we multiply that together, we get centimeters squared. What is a centimeter squared? It is a square that is 1 centimeter square would be 1 centimeter by 1 centimeter. It covers a certain amount of space. Units that are squared cover areas. Areas cover a flat space. So we are saying that it would take 24 of these to cover both sides. It would take 40 of these to cover the front and back. And in total, and I'm going to use SA for surface area, the total surface area would be adding these all up. So we would add 30 plus 24 plus 40, and we would get 94 centimeters squared. So to cover that whole box, we would have to paint 94 of these squares. It's important to visualize things when you're talking about areas and volumes so that you get an idea of how much space does something cover. Right? When you buy a can of paint, it'll say on there how many meters squared it will cover. And then you have to think of a meter stick, right? 1 meter is like this by this. That's how big 1 meter squared is. So you look at your can of paint, and then you can be like, okay, I can imagine putting those squares up on my wall gives me an idea of how much this can of paint will cover. That could be important because you need to buy a certain amount of paint. And why can't you return paint? Some paints you can return, some paints you can't. Do you know why? If you just buy the normal white paint just off the shelf, no problem. But if you go and say, I would like this to become fluorescent pink. What's the problem with returning fluorescent pink back to the store? No one's going to buy it. I don't know if you can mix. There must be someone.
No, but if they do the mixed tint, then you can buy your paint cheaper if you get mixed
right.
tint too, right?
So
they will try to resell it, just
at a discounted price. So you might not. The only time but I don't think you're allowed to return it.
No.
The only time is if they mix it and they screw up.
Yeah.
You're like, I like blue paint. Okay. Here's orange. You're like, that's wrong. Then they'd be like, oh yeah, you said blue. I did orange. That's bad. Then they would have to sell the orange paint on its own separate. Okay. Next question. Triangular prism. Can you see that it only has 5 sides? And now we also need to know our formula for the area of a triangle, which I think you probably should have it memorized already, but still on your formula sheet for grade 10. It will not be on your formula sheet for grade 11. I mean, once you get to the AP calculus class in grade 12, there is no formula sheet at all for all the new formulas and old formulas. So starting to know them already and remember as many as you can is going to be helpful for later on. Okay? I love the area of a triangle formula. It's just, to me it makes so much sense. If you know the area of a rectangle is base length times width, but if I call my length base and I call my width height, and you join the two diagonals together, does that not cut that rectangle perfectly in half? So, the area of a triangle might be easy to remember as base times height divided by 2. And then someone says, well, what happens if it's like if the height is here? Well, this triangle on this side is half of that rectangle. This triangle on this side is half of that rectangle. And so the area of the triangle is still half of that big rectangle in total. Sorry, I told you at the beginning, I get excited about certain things in math. I think this is fascinating, how you can make a connection from one formula to the other. And I find when you make those connections, you also find that those formulas are easier to remember, because they kind of make sense now, instead of just some random thing. Well, why is it divided by 2? Well, now there's kind of an explanation. Okay, sorry. Oh, I could just get off topic. Gives me goosebumps all day. But we'll do some of the math we're supposed to do. So, what we're going to do on this question right here is we are going to add some numbers for this one. Maybe I'll leave this one because I didn't give you a lot of space. sometimes I'll have to apologize because I don't give you enough, if I don't give you enough space, I try my best to leave enough space to do each question. I was going to make some numbers and we could do that one, but when I look at your page, there's not enough space. We'll get to it in a future example. Here's something really cool. This is a cylinder, kind of like my mug right here. What is a cylinder? A cylinder has a circle on the bottom that goes all the way up and has a circle on the top. If you're drawing a cylinder, when you draw a circle in 3 dimensions, do you know that you sort of draw an oval? Like, and then you would imagine the same oval on the bottom, but on one of them you'd have to have a dotted line because you wouldn't see it in the background. Cool idea number 1. I'm going to, I thought I had, no, I'm looking for something else that was in my room that seems to have disappeared. But I was looking for, I had a thermos in here that I always like doing with this example, but my Gatorade bottle will be okay. Gatorade bottle's not a perfect cylinder, right? Because they made it a little bit curvy in here. But can you imagine it being straight up and down? Now we're going to figure out the surface area of a cylinder. The surface area of a cylinder, well, it has what shape on the bottom? Circle. And it would also have that same shape on the top, although the Gatorade bottle has the spout. So when I want to figure out the surface area, I would have a circle on the bottom and a circle on the top. That shows up in the formula. Do you remember that the area of a circle is pi r squared? That shows up as 2 pi r squared because there's 1 circle on the bottom, 1 circle on the top. Now, the hard part to visualize is the surface area of this shape that goes around. Okay? That's hard to visualize. The best way to visualize what it is, go home tonight, and if your parents have any canned goods, like tomato soup, mushroom soup, or canned tomatoes, pull the label off. If you pull the label off, you will see what shape it is, right? Right? I just made a label for the Gatorade bottle. If I pull it off, it's a perfect rectangle. If you don't believe me that it's going to be a rectangle, go home, every soup container, keep pulling them off until you're convinced. And then your parents are going to be really happy. Because you're going to have all these cans peeled and you won't look at and put them on in different, mix them up. That'll go over really well too. Yeah, it's kind of funny.
Yeah.
Funny. It's funny until you get in trouble. Right? But it's like surprise supper. We were going to have spaghetti and tomato sauce, and now we're having spaghetti and kidney beans. Anyways, so you get a rectangle. Now, that rectangle, when you open it up, okay? When you open up, can you see that this part is perfectly the height of your cylinder? That this part of the rectangle is perfectly the height of the cylinder. And this part of the rectangle, if I put it on, and if it matched up perfectly, that's why I really want my cylinder, because my cylinder was like almost perfect. Anyways, I guess it died when they cleaned my room in summer. This is called what on a circle? Circumference. And we have, this is yours or something. We have a formula for circumference that is circumference is 2 times pi times r. That formula is still on your formula sheet too. It's right there. It says C equals 2 pi r. That's another thing. Even though you have a formula sheet, if there's a formula on your formula sheet that you don't know what it means, it's not very helpful, right? So there we've got our circumference formula. So then this area is a rectangle, and it's just 2 pi r times h. Putting that all together, we get this formula for your surface area of a cylinder. I do not have that formula memorized, because every time I want to figure it out, I just think about these 3 shapes, and I can make it right away. So again, if a formula makes sense, you'll remember it. I guess technically I have it memorized.
The interruption would
but
all
not-
those students volunteer to help out in terms of the fair that we're gonna have to showcase all of the events that go on in the school. Please come down to the gym if you're somebody who's volunteered to be at the table to help out in terms of showing what we offer here at the school. Come now to the gym to get the tables organized. Thank you so much.
So I will have, I'll keep making the videos. So for those of you that have to leave early, you'll be able to watch the end of this video and make sure you fill in your notes from there. So there's our cylinder and where the formula comes from. I want you to try this one on your own. I'm going to help you a little bit with the setup so that you have enough room. One of the things with these questions is that we have to do a lot of easy calculations. It's very easy to become unorganized when you do your math. Oh, I'll do an easy calculation up here, and one down here, and one over there. So one of the things we want to try to do when we have to do lots of easy calculations is be organized. So if I want to calculate the surface area of the following prisms, to be organized, I'm going to do what I did before. I'm going to do top and bottom, leave some space for that. Then I want to do the sides, leave some space for that, and the front and back. So I'm sort of organizing it a little bit already. I'm imagining how I could write that out so it's nicely and organized on my paper, and then I'm going to add all of those up. Okay? I would like you to try that on your own. And then you will also, let's do the setup for the cylinder as well. For the cylinder one, since there is a nice surface area of cylinder formula on your formula sheet, I would write out the formula first, and then put brackets for the R, which is the radius, put brackets for the H, and fill in the numbers based on the diagram. So I'm going to let you try both of those. We'll put up the answers in a bit.
Excuse the interruption, Huskies. At this time, we are going to ask all of our grade 9s and their teachers, all of their grade 9 classes and their teachers, head down to the gym and check out the clubs, teams, activities. You have to sign up for at least 2 things, so this is an opportunity for you to put your name down on a piece of paper. Make sure you print your name legibly and your grade. This is also open for all of our new students as well. We're going to keep it going a little while after lunch as well, so make your way down, check out the clubs, and if you're not a new student, you can come check them out too, because get yourselves involved. That's the only way to do it here. So don't forget as well too, there's a piece of lunch happening outside the front door, so go get
1,500, 950 centimeters squared.
15,000?
15,000. Did I say 1,000?
Yeah.
Yeah, that was bad.
That's okay.
15,950. Did you remember the units? Awesome. Now, in the second one, I want to show you a couple things with the second one. The radius is 2, so wherever you have that 2, you plug that in. Plug that in. Height is 5. Now, whether you have a scientific calculator that you bought from the school or you have a graphing calculator that you got from the school, I hope that the versions of both of those allow you to type things exactly as you see into your calculator. So I'm going to take out a graphing calculator right here and slide it over so I can see it. It's important to know where your pi button is on a calculator at any time, because if you use 3.14, you're using a rounded value, and your final answer might be off a little bit. If your final answer is off a couple of decimal places, it's always going to be a half mark deduction. We never round our answer until the very end. So in this case, we want to make sure we know where our pi button is. If you have a graphing calculator, your pi button is above here. You have to hit the second button. So I go 2 pi, I can put a bracket in, and I can type this exactly as I see. Even with brackets. And the calculator is smart enough and knows what it's doing and can do all of those calculations. Okay? So this gives me an approximated answer. I'm just going to write it at the bottom because I do want to show you something else with this question as well. 87.96. And one of the things that is going to be also very important in questions is when you are rounding, you should go back to the original question and check, did they say anything about rounding? Because sometimes the question will say round to 2 decimal places or round to the nearest 100. Then you have to be careful, because if you round not enough decimal places or too many decimal places, it's another half mark deduction for not paying attention to details. This one doesn't say what to round to, so you have the ability to choose. I'm going to do 2 decimal places here. Again, our units are centimeters. We're dealing with area, so that'll be centimeters squared. I used approximation signs because that is not perfectly accurate, because I rounded. Okay? Now, sometimes with questions with pi, and this is going to be especially true once you get to grade 12 math next year. That's kind of crazy to think about, right? But a lot of you will be taking the grade 12 math next year. They will be asking you to keep things exact and not round. So what does this mean for this question? Well, and it would be no longer a calculator question. It would be a non-calculator question. So I needed the calculator to get the decimals, but without a calculator, I can do some mental math. Mental math here would say, I have 2 squared, which is 4, times another 2, which is 8, still times pi, but I'm going to leave that as 8 times pi, or 8 pi. Same thing here. 2 times 5 is 10, times 2, that gives me 20, and it's still times pi, which is 20 pi. What do you think 8 pi plus 20 pi would be? 28 pi. In mathematics, we would call this an exact answer. And this because it's been rounded, an approximation. Yes. It's close. This is a good question. Oh, now you're gonna get me off topic on something I like a lot. Okay? Some people say pi is equal to 3.14. It is not. Okay? Some people say pi is equal to 22/7. And I don't know how good your mental math is. 22 divided by 7 is 3.142857 repeated. If you do the mental math. So you know your decimals. Pi is 3.1. How many decimals will have memorized? Do you know the next one?
19265.
Is it for sure a 4?
Yes.
Or is it rounded on your calculator? You don't know. I mean, to really know, you could go to the computer. You could go to calculator, or see if here I have a book just on pi. And in this book just on pi, right at the beginning in very small print, it starts with 3.1415926, and it is actually a 5.3 because it's rounded. 5.38979.3, and it keeps going. In fact, this book it keeps going. Every page has more decimal places until it gets to the very end, and the 1 millionth digit of pi happens to be 1. So if you would like to, you could start memorizing pi to see if you could get the world record. Actually, I don't think you'll get the world record. I will tell you a story about, let's see here. Hideaki Tomoyori. Hideaki Tomoyori memorized 40,000 decimal places of pi. Well, I don't know. Is that a really good use of time?
Yeah.
Yeah? Like what I'm a math guy. I like math a lot, but what is worse? To be the guy that memorized the 40,000 places, or to be the person that had to be checking it as he was saying it out loud? It took him 17 hours and 21 minutes in a row to say them all out. And you're the person checking them. You know what's the worst thing if you're the person checking? It's about 2 hours in, you go, oh, sorry, what was that?
Yeah. Or somebody starts saying numbers
Can
beside
you start over again? I lost count.
Or go by and go 27,
Right?
32, you know.
That would be crazy. But 17 hours just saying decimal places. Now, this book, here we go. So this book is all about pi. This book is all about crazy mental math strategies. Okay? This like crazy. Like I've got pretty good mental math strategies. Like here, I went 22/7 in my head to 6 decimal places repeated pretty quickly. I have some good mental math strategies. This book, if you want to take it out, like they start getting you doing some crazy things. Like you want to learn the strategies in here, some of the stuff that they get you to do is like in your head, what's 792 times 46? Okay. Then a little bit further on, they're like, what is, well, let's see, some other crazy questions in here. What's 5,312 squared? It's crazy. And these are your practice questions. Once you've read the chapter, they're like, if you practice this, you should be able to do it. They even have strategies for memorizing pi in this book. Anyways. I got off topic, I'm sorry. But that is a good place to end.